Hello my dear students, so how are you all? A very good evening to all of you. So welcome to Master School Foundation program. So successfully we completed 2 weeks, okay. Now we are in third week. So hope all of you are enjoying these classes by staying at your home. So observing only some students are attending the class regularly, but some students are attending the classes occasionally. So if you are not serious about your IIT examination, if your dream is to get the best rank in IIT examination, so these classes are the most important classes. So that's why my dear children, again I am requesting you all, so please follow the classes every day, please follow the classes regularly, okay now. So I want to see every student in 8th class after 5 years as IITian. So you have that capability, but here you have to do the work that is required, okay. So that's why every day we have only 2 classes from 5 to 6:30 in 2 different subjects, okay. So math, physics or physics, chemistry or maths, chemistry, so like that. So that's why if you are follow these classes so regularly and seriously, definitely you will crack the IIT seat after 5 years, there is no doubt. So here it is not easy to get the IIT seat, but if your aim is to get the IIT seat only, and with respect to that, if your work is like that, then definitely you will get the IIT seat. So there is no doubt. So everyone will get the IIT seat when they are serious about their preparation, okay. So if you follow the classes 2 days, and if you are not following the class again 2 days, then you are not able to get the best rank in IIT. So if you are not following the classes regularly, then you are not able to understand the remaining concepts or problems whatever may be in following classes, okay. If some student is there, if he or she didn't follow the class related to divisibility rules, then she or he is not able to understand the problems related to that concept. So my dear students, so please keep these words in our mind, okay, and you have the capability of getting the IIT seat, so there is no doubt. So if you are very serious about your preparation, definitely after 5 years you will get the IIT seat. So it is 100% correct, but before that you have to very serious about your preparation, then only there is a chance to get the IIT seat, okay. My dear children, wish you all the best. So now let us start the class today. In last class we discussed the concepts, what is the unit, what are the prime integers, what are the composite numbers, and what are the twin prime numbers, and what are the co-prime numbers, and what is a perfect number. So with respect to those concepts, today we can do some mains model problems. So today we are going to do the mains model problems related to the concepts which we discussed in last class. In last class we discussed the concepts, so unit, prime integers, composite numbers, twin primes, co-primes, and a perfect number. Now we are doing the problems related to these concepts. Now let us start the class. So we are doing the mains model problems. So you know what the mains model problems are, already we did some problems. So with respect to the given problem, so there exist 4 options. Out of these 4 options, only one option is correct. We have to choose that correct option by solving the problem only. So already I told you, don't guess the answer. If you guess the answer, that may be either correct or not. But if you solve the problem by using the concepts or definition or formula with respect to that problem, then definitely you will get the correct answer, okay. Now here the problem is, which of the following is a perfect number? Which of the following is a perfect number? To solve this problem, we have to recap the perfect number. So we must know the concept of perfect number. So when can we say the number is a perfect number, okay. So what is the definition of perfect number? A number is said to be a perfect number if the sum of all digits of this number is equal to 2 times of the given number. If you suppose that n is the given number, by adding all the digits of this number, by adding all the factors, of this number, if we get that is equal to 2 times of n, means 2 into n, then we can say the number n is a perfect number. So already, we have taken one example, that is 6, by writing the factors of 6, 1, 2, 3 and 6. By writing all the factors of 6, we have 1, 2, 3, 6. By adding 1 plus 2, 3, 3 plus 3, 6, 6 plus 6 is 12. 1 plus 2, 3, 3 plus 3, 6, 6 plus 6 is 12, where 12 is nothing but 2 times of 6. So, that is why 6 is a perfect number. If the sum of all factors of the given number n is equal to 2 times of n, that is nothing but 2n, then we can say n is a perfect number. Let us apply that concept to the given 4 options by observing option A. In option A, we have 2, the factors of 2 are 1 and 2 only. So, clearly that is a prime integer, 2 is the even prime integer. By adding the factors, you will get 1 plus 2, 3, but this is not 2 times of 2 into 2, because 2 times of 2 is 4, but here we got 3. So, that is why A is not a perfect number. If the sum of all factors of the given number n is equal to 2n, then only we can say n is a perfect number. But here by adding the factors of 2, that is 1 plus 2, so we have gotten 3, that is not equal to 2 into 2. So, that is why where 2 is not a perfect number. If we take option B, here we have 4. By taking that factors of 4, 1, 2 and 4. By taking the factors of 4, we have 1, 2, 4. By adding these 3 digits, 1 plus 2 plus 4. By adding these 3 digits, we have 1 plus 2 plus 4, where 1 plus 2, 3, 3 plus 4 is 7. 1 plus 2, 3, 3 plus 4 is 7. So, by multiplying 4 by 2, so 2 into 4 is 8. Here also option B can be eliminated. N must be equal to, n means the given number. So, take the factors of n, add them, that the sum of those factors must be equal to 2n. So, according to that, this is not a perfect number. If you take 7, the factors of 7 are 1 and 7. The factors of 7 are known as 1 and 7. By adding 1 and 7, you will get 1 plus 7 equal to 8. But this is not equal to 2 times of 7, that is 14. So, that is why C is also not a perfect number. So, since the first 3 options A, B, C are not correct, then we can take D is the correct option while writing the examination. But here let us check whether 28 is a perfect number or not. But while writing the examination, the first 3 options A, B, C are eliminated. So, since the first 3 options A, B, C are eliminated, then we can take option D as the correct option. Here let us check whether 28 is a perfect number or not. So, by taking the factors of 28, 1, 2, 14 times, 3, 4, 7 times. So, 5, 6, 7, 4 times, 8, 9, 10, 11, 12, 13, 14 2 times and 28. So, these are the factors of 28. By adding 2 plus 4, 6, 6 plus 7, 13, 13 plus 14, 27. So, 27 plus 28. Here 28, here you have to get 2 into 28 as 56. 2 into 28 as 56 by adding the digits 1 plus 2, 3, 3 plus 4, 7, 7 plus 7, 14, 14 plus 14, 28, 28 plus 28 is 56, that is equal to 2 times of the given number 2 into 28. So, that is why we can say 28 is a perfect number. So, for the given problem we can take option D is the correct option. We can say option D is the correct option for the given problem. So, which of the following is a perfect number? According to the definition of a perfect number, a number n is said to be a perfect number if the sum of all factors of n is equal to 2n. By applying the concept to the given 4 options, 28 is only the perfect number, because by writing the factors of 28 we are getting 1, 2, 4, 7, 14 and 28. By adding all those factors we are getting 56, that is nothing but 2 into 28. 28 means given number, so that is why 28 is a perfect number. If the sum of all divisors of the given number n is equal to 2n, then we can say the given number n is a perfect number. So, which of the following are co-prime numbers? Which of the following are co-prime numbers? Twin primes and co-primes. So, twin primes means if the difference of two prime integers is 2, then we can say those are twin prime numbers. But here co-primes means two numbers are said to be co-prime numbers, yet the two numbers must not be prime numbers only. The two numbers may be prime integers or composite numbers, or one is prime number and another is composite number. But it is not necessary that the given two numbers are prime numbers only. If the GCD of two numbers is 1, if the GCD of two numbers is 1, then we can say those are co-prime numbers. Here by observing the options, in option A we have 7, 9, in option B we have 9, 12, in option C we have 10, 15, in option D we have 20, 25. By observing option A, where 7 is the prime number but 9 is the composite number. Option B, 9 and 12 both are composite numbers. In option C, both 10 and 15 are composite numbers. In option D, we have 20 and 25. These are composite numbers. But let us check whether the GCD of two numbers is 1 or not. For which option, if the GCD of two numbers is 1, then we can take that is the correct option for the given problem. Two numbers are co-prime numbers if their GCD is 1. Here the two numbers must not be prime numbers only. They may be prime numbers or composite numbers, or one is prime number and another is composite number. Let us take the first option A. Here option A is 7, 9. By observing the two numbers in option A, we have 7, 9. By observing option A, we have 7, 9. If the GCD of two numbers is 1, GCD is nothing but greatest common divisor. So, we know how to find the GCD of two numbers. Divide the greatest number by the smallest number. We have to continue this process up to getting the remainder as 0. So, for which number we are getting the remainder as 0, then that number is known as the GCD or HCF of the given two numbers. By applying the rule for the given 4 options, here the first option is A, that is 7, 9, where the greatest number is 9 and the least number is 7. If we divide the number 9 by 7, if we divide the number 9 by 7, if we get the GCD as 1, if we get the GCD of 7, 9 is 1, then we can say option A is correct and we do not want to check the remaining 4 options. Here 7 1 ja 7, 9 minus 7 is 2. Again by dividing 7 by 2, 2 3 ja 6, 7 minus 6 is 1. Again by dividing 2 by 1, 1 into 2 is 2, 0. So, where 1 is the GCD of 7, 9. So, we can take option A is correct option. So, 7, 9 are the co-prime integers. 7, 9 are the co-prime integers. Or if we take the general method, the factors of 7 are 1, 7 only. The factors of 9 are 1, 3 and 9. The factors of 7 are 1 and 7. The factors of 9 are 1, 3, 9. By observing only 1 is the common factor of both 7 and 9 and that is the greatest. So, 1 is the greatest common divisor of 7 and 9. So, because 7 and 9 are the smallest numbers, but the process is to find the GCD of the given two numbers, we have to divide the greatest number by the smallest number. We have to continue this process up to getting the remainder as 0. So, for which number we are getting the remainder as 0, then we can say that is the GCD of the given numbers. Then that is called the greatest common divisor of the given two numbers. So if the GCD of the given two numbers is 1, then we can say they are co-prime numbers. So option A is correct. We don't want to check the remaining 4 options. If you want to check, take 9, 12. Take 9, 12, where the greatest number is 12 and the least number is 9. By dividing 12 by 9, so 9 1 ja 9, 12 minus 9 is 3. By dividing 9 by 3, 3 times cancel, so 3 ja 9, 0. So we can say GCD of 9, 12 is 3. That's why option B is not correct. Similarly, we can check whether option C and D are correct or not. Divide 15 by 10, here divide 25 by 20. You will get the remainder as other than 1. So that's why they are not co-prime integers. So two numbers are said to be co-prime integers if the GCD of those two numbers must be 1. According to the definition of co-prime numbers, if the GCD of the given two numbers is 1, then we can say the given numbers are co-prime numbers. Then the given numbers are co-prime numbers. By applying that property, that concept to the given 4 options, we are getting the GCD as 1 for the option A only, where option A contains the two numbers 7, 9. So that's why option A is the correct option for the given problem. If the GCD of given two numbers is 1, then we can say those two numbers are co-prime numbers. Remember, here the two numbers must not be prime numbers only. Here out of 7, 9, 7 is a prime number, but 9 is not a prime number. That is a composite number. The two numbers may be prime numbers or composite numbers, or one is prime number and another is composite number. So next, the least value of x and y so that the number 7x4 342y is divisible by 88. So actually we know the divisibility rules of 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13 like that. If we have the number like this, if you have the composite 2-digit composite numbers like this, we have to express that as the product of two numbers. We have to express that as the product of two numbers. 88 is there. 88 is there. So we can write 88 as 11 into 8. We can write 88 as 11 into 8. So we can write 88 as 11 into 8, where 88 is a composite number. So you have to express that as the product of one composite number and one prime number, where the prime number is 11 and the composite number is 8. If we have the numbers like this 88, 99, so like that, then we have to express the given number as the product of two numbers. In these two numbers, one is a prime number and another is a composite number. Now, any number divisible by both 11 and 8, any number divisible by both 11 and 8 will also divisible by 88. For example, if we take 6, to check whether the given number is divisible by 6 or not, we can write 6 as 2 into 3. Both are prime integers. 2 is a prime number, 3 is also a prime number. If the given number is divisible by both 2 and 3, then we can say the given number is also divisible by 6. If the given number is divisible by only one of 2 and 3, then we can say the given number is not divisible by 6. If you take 15, 15 is divisible by 3 but not by 2. That is why 15 is not divisible by 6. If you take 18, that is divisible by both 2 and 3. 2 9 times, 3 6 times. So 18 is also divisible by 6. So when a composite number is given, then we can express that as the product of two numbers. Here 11 and 8 are there. We know the divisibility rules of 2, 3, 4, 5, 7, 8, 9, 10, 11 and 13. So let us write the given number as the product of two numbers and we can check whether the number is divisible by both the numbers. If that number is divisible by both the number, then we can say that number is divisible by the given number. Here 88 is given. The least values of x and y so that the number 7x342y is divisible by 88. Is divisible by 88. So here one number is given, 1, 2, 3, 4, 5, 6 digits are there. In these 6 digits, x and y are the unknown digits. X and y are the unknown digits. We have to replace x and y by the given 4 options. We have to replace the values x and y by the given 4 options. So by replacing x and y by the given 4 options, that number must be divisible by both 80. So that number must be divisible by 88. The number is divisible by 88 is nothing but the number must be divisible by both 11 and 8. The number must be divisible by both 11 and 8. So here I am expressing 88 as 11 into 8. Here we have 7x342y. 7x342y. To check whether the number is divisible by 11 or not, we have to check. We have to take the difference of the sum of even digits and odd digits. If that is a multiple of 11 like 0, 11, 22, 33, 44, 99, then we can say the number is divisible by 11. By observing option A, we have 4 comma 4. In place of x by writing 4 and in place of y by writing 4, we can write 7, 4, 3, 4, 2, 4. So by taking the values of x and y from the option A as 4 comma 4, in place of x by writing 4 and in place of y by writing 4, here let us take the difference of sum of odd digits and even digits. Odd digits 7, 3 and 2. So 7 plus 3 plus 2 minus sum of even digits 4 plus 4 plus 4. 4 plus 4 plus 4. 7 plus 3 10. 10 plus 2 12 minus 4 plus 4 8. 8 plus 4 12. 12 minus 12 is 0. So clearly we can say 0 is a multiple of 11. 0 is a multiple of 11. So that's why the number 743424 must be divisible by 11. Here by taking the difference of sum of odd digits and even digits, finally we have gotten 0. Clearly we can say 0 is a multiple of 11. So that's why the number 743424 is divisible by 11. Let us check whether the number is divisible by 8 or not. Here the divisibility rule of 8 is, if the last 3 digits of the given number is divisible by 8, then we can say the number is divisible by 8. So what is the divisibility rule of 8? If the last 3 digits of the given number, if the number in the last 3 digits of the given number is divisible by 8, then we can say the number is divisible by 8, where the number in last 3 digits is 424. So by checking whether it is divisible by 8 or not, 8 5s are 40, 42 minus 42, 24, 8 3s are 24, where the remainder is 0. So that's why the number 743424 is divisible by both 8 and 11. So that's why we can take option A is the correct option. So since option A is correct, then we don't want to check the remaining options are correct or not, because here for every problem in mains model exam only one correct option exists. Already we got the first option A is correct for the given problem. So that's why we don't want to check whether the remaining options are correct or not. If you want to check, here I am taking B. Similarly you can check option C and option D. In option D we have 4 comma 3. Already we have checked by 4. Here 4 comma 4 are there. 4 comma 3 are there. In option A 4 comma 4 are there. Here we have 4 comma 3. In place of x and y by writing 7, in place of x by writing 4, 7 4 3 4 2 y. In place of y by writing 3. By writing 3. Here by taking the difference 7 plus 3 10, 10 plus 2 12, minus 4 plus 4 8, 8 plus 3 11, 12 minus 11 is 1 only. 7 plus 3 10, 10 plus 2 12, minus 4 plus 4 8, 8 plus 3 11, 12 minus 11 is 1, but here 1 is not a multiple of 11, so that's why we can eliminate option B. So similarly you can check whether options C and D are correct or not. In the examination you don't want to check, because already so we got the first option is correct. So that's why we need not to check the remaining options are correct or not. So that's why for the given problem, the least values of x and y, so that the number 7x342y is divisible by 88, where 88 is the composite number. 88 is the composite number. We have to express 88 as the product of two numbers. Out of these two numbers, one number is composite number and one is a prime number. So 88 can be written as 11 into 8. So any number divisible by both 11 and 8 will also divisible by 88. In option A we have 4 comma 4, that's why in place of x and y, by writing 4 comma 4 and by checking the number 743424 is divisible by 11 and 8. This is divisible by both 11 and 8. So the number, that's why the number 743424 must be divisible by 88. So we can take option A is the correct option for the given problem. Next, if the product 4864 into 9p2 is divisible by 12, then the value of p is, here 12 is given. 12 is given. We have to express 12 as the product of, we have to express 12 as the product of two numbers, where 12 can be written as 6 into 2. 12 can be written as 6 into 2. So where 6 is a composite number and 2 is a prime number. 6 is a composite number and 2 is a prime number. So in the above problem we have 88, so that's why we expressed 88 as 11 into 8. Here we have 12. By expressing 12 as 6 into 2, by expressing 12 as 6 into 2. So any number divisible by both 6 and 2 will also divisible by 12, will also divisible by 12. So here 6 3 ja 18, 2 9 ja 18. So if you take 18, so here we are expressing 12 as 6 into 2. Here we are expressing 6, if we express 12 as 6 into 2, if we express 12 as 6 into 2, if you take 24, 24 is divisible by, 24 is divisible by 12, 12 2 times, 6 4 ja 24 and 2 12 ja 24. Okay. So 12 4 ja 48, 6 8 ja 48 and 2 24 ja 48. So if the number is divisible by both 6 and 2, divisible by both 6 and 2, that will also divisible by 12, that will also divisible by 12. Okay. So if we take 18, 18 is divisible by 6 and 2. If we take 18, 18 is divisible by 6, 6 3 ja 18 and 18 by 2, if we take 18 by 2, 2 9 times cancel, but here 18 is not divisible by 12. Here the number 18 is not divisible by 12. So if you take 18, if you take 18, where 18 is divisible by both 6 and 2, both 6 and 2. So 6 3 ja 18, 2 9 times 18, 6 3 ja 18 and 2 9 times 18. But here if we take 12, 12 is not divisible by 18, 12 is not divisible by 18. So if we express 12 as 3 into 4, if you express 12 as 3 into 4, if any number divisible by 3 and 4, if any number divisible by 3 and 4, if any number divisible by 3 and 4, let us check whether the number is divisible by 12 or not. So here also if you take 18, 18 is divisible by 3 only, 18 is divisible by 3 only, 3 6 times, but 18 is not divisible by 4. So that's why the number 18 will not be divisible by 12. So let us consider one number which is divisible by both 3 and 4. Let us consider one number which is divisible by both 3 and 4. So if you take 24, if you take 24, where 24 is divisible by 3 8 times. So similarly if you take 24, so this is also divisible by 4 6 times. So that's why 24 is also divisible by 12 2 times. So here if you express 12 as 6 into 2, if you take 18, 18 is divisible by both 6 and 2, 6 3 ja 18 and 2 9 ja 18, but 18 is not divisible by 12. So if we express 12 as 3 into 4, if we express 12 as 3 into 4, if any number is divisible by both 3 and 4, if any number is divisible by both 3 and 4, then we can say that is divisible by 12. If you take 48, so this is divisible by 16, 3 16 times 48, and that is also divisible by 4, so that is 4 12 times. So if let us check whether this is divisible by 12 or not. So clearly 12 4 ja 48. So 12 4 ja 48. So if any number divisible by both 3 and 4, that is also divisible by 12. That is also divisible by 12. So if you take 54, so if you take 54, so we can say 54 is divisible by 3, 18 times. But if you take 54 by 4, this is not divisible. 54 is not divisible by 4, that is why 54 is also not divisible by 12. So any number divisible by both 3 and 4 will also divisible by 12. If you take 6 into 2, if you write 12 as 6 into 2, if any number divisible by both 6 and 2 may or may not divisible by 12. May and may not divisible by 12. If you take 12, 12 is divisible by 6 and 2. So 12 by 6 2 and 12 by 2 is 6. Similarly 12 by 12 is also, this is also correct. But if you take 18, 18 is divisible by 6 only. 18 is divisible by 6 3 times, and that is also divisible by 2, that is 9 times, but 18 by 12, this is not divisible. So that is why here let us write 12 as 3 into 4. So any number divisible by 3 and 4 will also divisible by 12. If you express 12 as 3 into 4, if you write 12 as 3 into 4, if one number is there, if we know that number is divisible by, both 3 and 4, then we can say that is also divisible by 12. Okay. Now here we have to find the value of P when the product 4864 into 9P2 is divisible by 12. Divisible by 12 is nothing but that must be divisible by 3 and 4. That must be divisible by 3 and 4. Here the number is given as 4864 into 9P2. So the into is there, that is not x, that is into 4864 into 9P2, means we have to multiply 4864 by 9P2. We have to multiply 4864 by 9P2, but here P is the unknown value. In place of P you may have 1, 2, 3 and 5. So in place of P, if you take 1, then we can write this as 4864 into 912. 4864 into 912. Here to check whether the number is divisible by 4 or not. So general method is, if the last 2 digits of the given number, must be divisible by 4. So here if you multiply 4864 by 912, if you multiply 4864 by 912, in place of P we are taking 1. So 912. So 2 4 ja 8, 2 6 ja 12, 2 8 ja 16 plus 1 17, 2 4 ja 8 plus 1 9. 2 4 ja 8, 2 6 ja 12, 2 8 ja 16 plus 1 17, 2 4 ja 8 plus 1 9. It's 1 into 4 4, 1 into 6 6, 1 into 8 8, 1 into 4 4. So next if you take 9, 9 4 ja 36, 9 6 ja 54 plus 3 57, 9 8 ja 72 plus 5 77, 9 4 ja 36 plus 7 43. Here we have 8, 2 plus 4 6, 6 plus 6 12 plus 7 19, 1 plus 7 8 plus 8 16 plus 9 25, 2 plus 7, 9, 9 plus 4, 13, 43 plus 1, 44. In place of P by taking 1. In place of P by taking 1. So, we have 4864 into 912. 4864 into 912. If we multiply 4864 by 912, we got this. 2 4 is 8, 2 6 is 12, 2 8 is 16 plus 1 17, 2 4 is 8 plus 1 9. Similarly, if you multiply by 1, 1 into 4 4, 1 into 6 6, 1 into 8 8, 1 into 4 is 4. If you multiply by 9, 9 4 is 36, 9 6 is 54 plus 3 57, 9 8 is 72 plus 5 77, 9 4 is 36 plus 7 43. By adding 8, 2 plus 4 6, 7 plus 6 13 plus 6 19, 1 plus 7 8, 8 plus 8 16 plus 9 25, 4 plus 7 11 plus 2 13, 1 plus 3 4 and 4. So, here we have 4 4 3 5 9 6 8. We have 4 4 3 5 9 6 8. So, by taking in place of P by 1 4 4 3 5 9 6 8. Here let us check whether this number is divisible by 4 or not, where the last 2 digits in the given number is 68. So, here by taking, let us check whether 68 is divisible by 4 or not. Here 4 1 is 4, 6 minus 4 2, 28. So, 4 7 is 28. So, 4 17 times. So, this is divisible by 4. Let us check whether this is divisible by 3 or not. If the sum of all digits of the given number is a multiple of 3, 4 plus 4 8, 8 plus 3 11, 11 plus 5 16, plus 9 25, plus 6 31, plus 8 39, 3 plus 9 12, 1 plus 2 3. 4 plus 4 8, 8 plus 3 11, 11 plus 5 16, plus 9 25, plus 6 31, plus 8 39. So, 39 means 3 plus 9 12. Again by adding these 2 digits 1 plus 2 3. So, clearly we can say 3 is a multiple of 3. So, that is why we can take option A is the correct option. We do not want to check whether the remaining options B, C, D are correct or not. So, if you want to check, in place of P take 2, in place of P take 3 and in place of P take 5 and check whether those numbers are divisible by both 3 and 4 are correct. So, that is why for the given problem the product 4864 into 9P2 is divisible by 12, then the value of P is 12 can be expressed as 4 into 3. Any number divisible by 4 into 3 will also divisible by 12. So, in place of P by taking option 1, option A, that is 1, and by simplifying that we got this number that is divisible by both 4 and 3. So, that is why the value of P is correct. So, option A is the correct option for the given problem. So, dear students, let us do some more problems related to these concepts